Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice for calculating confidence interval estimates for population standard deviations. Let's get started. So the first example problem we want to look at involves antifreeze. So chemical companies selling antifreeze in quantities of 3,785 milliliters. We want good quality control, which means our standard deviation needs to be small. And so the threshold value that we need to get below is 30 milliliters. And to assure this, we take a simple random sample of 24 containers off the line. So looking at this sample, we find that the mean volume of the antifreeze containers is 3,789 milliliters, and the standard deviation is 42.8. What is the 99% confidence interval estimate for the true value of the population standard deviation, which of course we want to be below 30? Well, StatCrunch, remember, calculates confidence intervals on the variance, not the standard deviation. Okay? So we've got to do a little legwork on our own, but we can use StatCrunch to do the bulk of our calculation. So most of our heavy lifting, StatCrunch is going to do for us. We just have to do a little bit of extra legwork. Wait, standard deviation is a bias estimator. How do we get away with using the sample standard deviation to target the population standard deviation? Do you remember that justification from the prior mini lecture? Well, I hope you're saying that yes, standard deviation is a bias estimator, but standard deviation is also the square root of the variance, and the variance is an unbiased estimator. So we're actually able to do this going through the back door by cutting through the variance's property, and it's through the variance that we're able to get from one to the other. So that's why we can use a bias estimator as our point estimate. And that's exactly what we're going to do when we use StatCrunch. We're going to go through the variance. So in StatCrunch, go to Stat, Variance Stats, One Sample with Summary. It's typically what you're going to go off on. And then here in the Options window, notice the numbers that we're putting in. So this first number up here is not the standard deviation. Remember, the standard deviation for a sample was 42.8. But notice here the field is titled Sample Variance. So to get the variance, which you're typically not going to be given in a problem statement, you're typically going to be given the sample standard deviation. So to get the variance, you're going to have to take that standard deviation and square it. That gives you the variance. So that's a number that gets put in that first field. And then in the second field, notice that this is not degrees of freedom. This is actual sample size. So don't subtract 1 and then put the number in. Just take the number for the sample and put it in. Once you do that, make sure you've got your radio button for confidence interval selected with the appropriate confidence level. Hit compute, and out comes your results. But notice that this is the upper and lower limit for confidence interval on the variance. Notice the term variance here, variance of the population. So if you're looking for standard deviation, you've got to take the square root of the variance. And that's what you do with your upper and lower limit. You're going to take the square root of those numbers to get the upper and lower limit of your CI on standard deviation. So we take those numbers that we see in StatCrunch and take the square root. That gives us our CI on the standard deviation. So even though standard deviation is a bias estimator, we can use it as our point estimate if we go through the unbiased estimator that is the variance. Now, does this CI suggest that the variation level is acceptable? Remember, 30 was our threshold. Look at your CI. What say you? Well, I hope you said that it's not acceptable because 30 is outside the CI. In fact, the entire CI is greater than 30. We need to get below 30, okay? Because 30 is our threshold, because we're looking at standard deviation, which, remember, is a measure of the spread of the data. So it's a measure of variation. Well, you want to decrease the variation in order to increase your quality control. So decreased quality control comes when you have more variation. Okay, so the fact that our sample, the fact that our confidence interval is greater than our threshold value, not less, but greater, it says we have more variation in our process than what we can reasonably tolerate. And so, no, this level of variation is not acceptable. Let's go back to looking at the mercury levels in sushi. We've got our data here from 7 different supermarkets, along with the sample mean and sample standard deviation. So now, instead of looking at the mean value, let's look at the standard deviation. What's the 90% confidence interval estimate for the population standard deviation for the amount of mercury in tuna sushi? Why don't you stop the video here and then go try to work this problem, and then when you get done, come back and we'll see how well you did. Okay, let's see how you did with this. So, first we're going to go into StatCrunch. Go to Stat, Variance Stats, one sample with summary. I use my summary stats. Notice the number I'm putting in that first field. Okay, our standard deviation is 0.366. But the number I put in is 0.133956 because that is the sample variance. What I'm given in the problem statement is the standard deviation. So I have to square that number in order to get the variance. Again, this is the sample size, not degrees of freedom. And then down below, the 90% for our confidence interval. Go ahead and punch compute. Out comes my results. And here we've got the lower and upper limit. But remember, this is for variance. So again, if we want standard deviation for our CI, it means we have to take the square root of the numbers that we find there in our table in the results window. When we do, that gives us 0.253 to 0.701. And there's our CI. We can also express it as 0.253, 0.701. So given that 0.477 plus or minus 0.224 also results in values of 0.253 and 0.701, can we express our CI also in this format? The answer to that is going to be no. The standard deviation is typically not centered within the CI, and that's because it's based on the chi-square distribution, which is a skewed distribution. Very quickly, let's look at one last example problem, going back to our brain volume example. So here we've got data for brain volumes, and we were looking for a 99% confidence interval on the population standard deviation. So back in StatCrunch, Stat, Variance Stats, one sample with data. So in my window here, notice if I put actual data values in StatCrunch, I can actually select with data. So I select the column with the data, put the radio button next to confidence interval, 99% level, and then out comes the results for the variance. I take the square root of those numbers to get the confidence interval estimate for standard deviation. How does this compare with our earlier assumption that the population standard deviation is 125.96? Well, it's inside the confidence interval, so it's going to compare very well. And that brings us to the end of this mini lecture. Thanks for watching. I'll see you in the next video.